Deep sky surveys show that galaxies are often found in groups and clusters. Solitary galaxies that have not significantly interacted with other galaxies of comparable mass in the past billion years are relatively scarce. Only about 5% of the galaxies surveyed are truly isolated. However, they may have interacted and even merged with other galaxies in the past, and may still be orbited by smaller satellite galaxies. Isolated galaxies can produce stars at a higher rate than normal, as their gas is not being stripped by other nearby galaxies. On the largest scale, the universe is continually expanding, resulting in an average increase in the separation between individual galaxies. See Hubble's law. Associations of galaxies can overcome this expansion on a local scale through their mutual gravitational attraction. These associations formed early, as clumps of dark matter pulled their respective galaxies together. Nearby groups later merged to form larger-scale clusters. This ongoing merging process, as well as an influx of infalling gas, heats the intergalactic gas in a cluster to very high temperatures of 30 to 100 megakelvins. About 70 to 80% of a cluster's mass is in the form of dark matter, with 10 to 30% consisting of this heated gas and the remaining few percent in the form of galaxies. Most galaxies are gravitationally bound to a number of other galaxies. These form a fractal-like hierarchical distribution of clustered structures, with the smallest such associations being termed groups. A group of galaxies is the most common type of galactic cluster. These formations contain the majority of galaxies, as well as most of the baryonic mass in the universe. To remain gravitationally bound to such a group, each member galaxy must have a sufficiently low velocity to prevent it from escaping. See virial theorem. If there is insufficient kinetic energy, however, the group may evolve into a smaller number of galaxies through mergers. Clusters of galaxies consist of hundreds to thousands of galaxies bound together by gravity. Clusters of galaxies are often dominated by a single giant elliptical galaxy, known as the brightest cluster galaxy, which, over time, tidally destroys its satellite galaxies and adds their mass to its own. Quote, superclusters contain tens of thousands of galaxies, which are found in clusters, groups and sometimes individually. At the supercluster scale, galaxies are arranged into sheets and filaments surrounding vast empty voids. Above this scale, the universe appears to be the same in all directions, isotropic and homogeneous, though this notion has been challenged in recent years by numerous findings of large-scale structures that appear to be exceeding this scale. The Hercules Corona Borealis Great Wall, currently the largest structure in the universe found so far, is 10 billion light-years, 3 gigaparsecs, in length. The Milky Way galaxy is a member of an association named the Local Group, a relatively small group of galaxies that has a diameter of approximately 1 megaparsec. The Milky Way and the Andromeda Galaxy are the two brightest galaxies within the group. Many of the other member galaxies are dwarf companions of these two. The Local Group itself is a part of a cloud-like structure within the Virgo Supercluster, a large, extended structure of groups and clusters of galaxies centered on the Virgo cluster. And the Virgo Supercluster itself is a part of the Pisces Cetus Supercluster complex, a giant galaxy filament,